So how do we go about testing accuracy? We know that that's the harder one to do because we can't just do it with normal statistics. We actually have to do a thoughtful analysis and compare it against something else, while also understanding that we're still going to have randomness in both sets of measurements. The measurement of our reference and the measurement of our analyte. So one way to do that, and I brought this up in our last video, is to use a standard reference material where things are very well known. Typically NIST is where you'd get that, in this country at least, but there's other places that you can get SRMs or certified reference materials. And if you're working in a biomedical field, they may have some that are more built for the medical industry and also for research labs that are in biomedical sciences. Now, you could also choose to use two different methods. In other words, maybe you try doing it with doing a measurement with a pH meter, but you also use a spectrometer and a pH indicator dye. And you say, let's compare the results from these two totally different phenomena to see if they give the exact same result or close enough for us to believe. That should be within our expected precision. We can also do a trick like this. We can take a blank, so everything in there except for our sample. Now we're going to add in a spike of our analyte. This was everything else that was present in our unknown, made from scratch. This is the thing that we're actually measuring, and then we can go ahead and do a bunch of measurements to see exactly where we can see things, see if our calibration curve we can build is very linear, and make sure that our values are reading correctly. We want to go over a pretty good range there, though. We want to go from about half the concentration to about 1.5 times the concentration that we were expecting, because you never know exactly where it's going to be. And don't forget, there's some techniques like spectroscopy where there's a linear range, but then your detector maxes out and you can't see anything above it. So we need to do this to make sure that we don't end up with our measurements way out here. So if we're expecting our value to be about here, we'll do a measurement here, and we'll do a measurement here where we've made up our own concentrations. So that's one possibility. Now, here's the thing. Suppose you got something complicated where it's really hard to find A, B, and C and add them all together. Artificial salt water, yeah, you can make that pretty easily to make your own fake matrix. What about human blood? That's a wee bit trickier. Instead, what we do is something called standard addition. Now in standard addition, what we do is we take the sample. Let's just say that it's a sample of blood. It's got all that complexity. Maybe we're trying to measure the amount of zinc that's in the blood. So what we can do is we can measure the absorbance with nothing else added. So this will be 0 spike added. I'm going to be vague about my units because obviously it could be milliliters, it could be micrograms, it could be moles, it could be atoms, lots of things. We'll just keep it very conceptual here. Let's just say that when we didn't add anything, we saw this much signal coming from the zinc present. Now we'll add in a certain amount that we know. We'll take another measurement and look at how it's gone up. Now if we extrapolate backwards, the slope of this line should tell us basically how much negative volume we would have added to make our sample in the original place. In other words, this is going to be the standard that we're adding. You use that concentration. You say, theoretically, we had negative this many milliliters that were already there, or grams or whatever. So you just plug that into your equation. You find out how many units you would have added to get up to that starting point and multiply that by your concentration. Congratulations, you now know how much was present. Not only that, you don't have to do just one spike. You can continually add more and more spike, so you have a really good line, and you also have all of those statistics about the quality of your line, like R squared and things like that. Now those are ways that you can measure the accuracy of a method. The main thing that you'll do now is you'll say, okay, now that I know exactly how much I've done, I also want to check for my spike recovery. In other words, if I do this experiment, how much of the piece that I've added do I end up seeing when it makes this change? We'll see some examples of how you can actually determine that as part of our workshop.